Hello and welcome to my channel. Around the world, malaria is the most significant parasitic disease of humans and claims the lives of more children worldwide than any other infectious disease. Since the year 1900, the area of the world exposed to malaria has been halved, yet 2 billion more people are presently exposed. WHO World Malaria Report in 2019 states that an estimated 228 million cases of malaria occur worldwide in 2018, causing 405,000 deaths in the year 2018. Many under the age of 5 years died. Also, 19 sub-Saharan African countries and India carried approximately 85% of the global malaria burden. The most prevalent and pathogenic malaria parasite most commonly associated with severe illness and death, especially in the WHO African region, accounting for 99.7% of malaria cases, is Plasmodium falciparum. It is also highly prevalent in Southeast Asia, Eastern Mediterranean, and then Western Pacific regions. The most vulnerable group affected by malaria in high transmission areas are children younger than 5 years old. Their deaths accounting for 67% of the global malaria deaths. In low transmission areas, all ages are at risk due to low immunity. The organism itself was first seen by Laveran on November 6, 1880 at a military hospital in Constantine, Algeria, when he discovered a microgametocyte. Patrick Manson in 1894 hypothesized that mosquito could transmit malaria. This hypothesis was experimentally confirmed independently by Giovanni Battista Grassi and Ronald Rose in 1898. Malaria is a mosquito-borne disease caused by 5 protozoa: Plasmodium falciparum, Plasmodium vivax, Plasmodium malariae, Plasmodium ovale, and most recently implicated Plasmodium knowlesi. Infection with Plasmodium falciparum is being accounted for more than 90% of the world's malaria mortality and therefore remains an important threat to public health on a global scale. Malaria is endemic in more than 90 countries, affecting approximately 40% of the world's population. Based on present predictions for climate change, researchers predict an increase in the geographical distribution of malaria and an increasingly suitable climate for malaria transmission in tropical regions. Susceptibility to malaria infection increases during pregnancy. Plasmodium falciparum infects pregnant women more often and more severely than non-pregnant women, partially due to pregnancy-induced sex and mediated immunity depression. Pregnant women in the second trimester are at greatest risk of infections, although the risk is somewhat affected by age and gravidity, with young primi-gravidae being at the highest risk at high transmission areas. Anopheles mosquitoes are slender and usually have a dark brownish-black coloration. Anopheles lay their eggs in marshy areas or near the banks of shallow creeks and streams. Adult female mosquito lay 50 to 200 eggs at a time. The eggs float on the surface of the water. Eggs do not tolerate drying out. Larvae live in the water. It usually takes 10 to 14 days for an egg to develop into an adult mosquito. Anopheles larvae breathe by using special organs called spiracles located on their abdomen. Larvae shed their skin or mold 4 times during their stage before becoming a pupae. They have distinct characteristics such as long, pointed proboscis for feeding on blood, and their wings have a characteristic pattern of dark and light spots. Pupae live in water. Pupae do not have external mouthparts, so they do not eat during this stage. An adult mosquito emerges from a pupa and flies away. Adult female Anopheles mosquito bite people and animals, usually late in the evening or at night. Female mosquitoes need blood to produce eggs. Adult female Anopheles mosquitoes prefer to feed on people or animals such as cattle. Some Anopheles male mosquitoes fly in large swarms, usually around dusk, and the female fly in the swarm to mate. After blood feeding, a female mosquito rests for a few days while the blood digests and the eggs develop. After the eggs develop, the female lay them in water source. Anopheles mosquitoes generally don't fly more than 1.2 miles, that is 2 kilometers from their larval habitat. Anopheles mosquitoes are attracted to dark, sheltered areas for resting during daytime. When an infected Anopheles mosquito bites a person, it injects the malaria parasite, that's Plasmodium, along with its saliva into the person's bloodstream. The parasite then travels to the liver where they multiply and mature. Once mature, the parasite re-enter the bloodstream and infect red blood cells, causing them to rupture and release more parasite into the bloodstream. This cycle of infection and rupture leads to the symptoms of malaria. The gametocyte, which the male contain microgametocyte and the female is macrogametocyte, are ingested by an Anopheles mosquito during blood meal. The parasite multiplication in the mosquito is known as the sporogonic cycle. While in the mosquito's stomach, the macrogametes penetrate the macrogamete, generating zygotes. The zygotes in turn become motile and elongated okinite, which invade the midgut walls of the mosquitoes, where they develop into oocytes. After 10 to 18 days, a form of the parasite called sporozoite migrates to the mosquito's salivary glands. When the Anopheles mosquito takes a blood meal on another human, anticoagulant saliva is injected together with the sporozoite, which migrate to the liver, thereby beginning a new cycle. Thus, the infected mosquitoes carry the disease from one human to another, acting as a vector, while infected humans transmit the parasite to the mosquito. In contrast to the human host, the mosquito's vector does not suffer from the presence of the parasite. The malaria parasite life cycle involves two hosts. Inoculations of the sporozoite into a new human host perpetuate the malaria life cycle. Sporozoites released from the salivary glands of the mosquitoes enter the bloodstream during feeding, quickly invading the liver cells, hepatocytes. During the next 14 days, in the case of Plasmodium falciparum, the liver stage parasites differentiate and undergo asexual multiplication, resulting in tens of thousands of merozoites that burst from the hepatocyte. Individual merozoites invade the red blood cells, that's erythrocytes, and undergo an additional run of multiplication, producing 12 to 16 merozoites within a season. The length of this erythrocytic stage of the parasite life cycle depends on parasite species. Irregular cycle for Plasmodium falciparum, 48 hours for Plasmodium vivax and Plasmodium ovale, 42 hours for Plasmodium malariae. The clinical manifestation of malaria fever and chills are associated with the synchronous rupture of the infected erythrocyte, the release the released merozoites go on to invade additional erythrocytes. Not all the merozoites divide into seasons. Some differentiate into sexual forms, male and female gametocytes. These gametocytes are taken up by a female Anopheles mosquito during the blood meal. Within the mosquito mate gut, the male gametocytes undergo a rapid nuclear division, producing 8 flagellated microgametes that fertilizes the female macrogamete. The resulting oconite traverses the mosquito gut wall and insists on the exterior of the gut wall as an oocyst. Soon the oocyst ruptures, releasing hundreds of sporozoites into the mosquito blood cavity, where they eventually migrate to the mosquito salivary glands. Within the 48 hours asexual blood stage cycle, the mature forms change the surface properties of infected red blood cells, causing them to stick to the blood vessels, a process called cytoadherence. This leads to obstruction of microcirculations and result in dysfunction of multiple organs, typically the brain, in cerebral malaria. Known malaria vectors include Anopheles gambiae, that's the principal vector, Anopheles abimanus, Anopheles freeborni, Anopheles maculatus, and Anopheles stevensi. The severity of the infection is affected by many factors, including the number of previous pregnancy, previous malaria infections and immunity, trimester of pregnancy, and comorbidity. Malaria symptoms can vary in severity, but typically include fever, chills, sweat, headache, muscle aches, and fatigue. In severe cases, malaria can lead to organ damage, anemia, and even death, particularly if left untreated. Treatments include anti-malaria drugs depending on the species of Plasmodium involved and the severity of the infection. Prompt and effective treatment is essential to prevent complications and fatalities. Its management and prognosis depend on the awareness of a possible diagnosis in travelers returning from endemic area, earlier recognition, and timely effective treatment. Prevention and control. Several measures can be taken to prevent malaria. Using bed nets treated with insecticide to prevent mosquito bite while sleeping. Taking anti-malaria medication while traveling to endemic area. Implementing vector control measures such as indoor residual spraying and insecticide. Eliminating or treating stagnant water source where Anopheles mosquito breed. Understanding their biology, habitat, and control measure is crucial in the fight against malaria, a disease that continues to impact millions of people worldwide. Vector surveillance, which includes the spatial distribution and density of mosquito vectors, could provide essential information to better understand the dynamics of malaria transmission and facilitate appropriate decisions regarding interventions. Distributions of the competent vector, as well as their vectorial capacity, contributes substantially to malaria endemicity. There are several factors determining the vectorial capacity of Anopheles mosquito to transmit Plasmodium parasite. This includes extrinsic incubation period of the parasite, daily survival of the mosquitoes, gonotropic cycle, and this gonotropic discordance of the mosquitoes, as well as the essential key element feeding and host seeking behavior of the mosquito. Thank you for watching and subscribe to my channel.